Hi everyone. So, of course, if you look at the title, so freedom of Kubernetes requires chaos engineering to shine in production, I guess you understand that we're going to talk about Kubernetes. And of course, chaos engineering. All right, so who I am. I think I'm going to do it with the traditional way. So who I am. That's funny. Okay, who I am. So my name is Henrik Rexed. I'm a cloud native advocate, not an evangelist, an advocate. So I understand the problems, the pain. Prior to Dynatrace, I've been working 15 plus years as a performance engineer. So performance is in my heart. So that's why I'm one of the producer of a YouTube channel called PerfBytes. So it's a dedicated YouTube channel and podcast where we produce content for performance engineers. And also a year ago, about that, I started a YouTube channel for observability because I thought, hey, there's nothing for observability, so let's create something. So I created a channel called Is It Observable? So it's not Does It Blend, it's Is It Observable? So if you want to look at the channel, feel free to do that. I need feedback to improve the content. So if you stay with me with the next 30 minutes or so, what are we going to talk about? And what are you going to learn about? So first, we're going to talk about Kubernetes. So I don't know how much you know about Kubernetes, so I make some few remindings about it. And we're going to talk about some challenges that impact the performance of our applications. So for this, of course, because we're going to use chaos engineering, so I will have to remind what is chaos engineering. And then once we have all the requirements, we can see what would be the experience that we could run to validate our changes in our Kubernetes settings. And of course, if you do testing or if you do experiments, you need obviously observability, you need metrics, you need events. So we're going to cover all those things. And last, which is not the last bullet point, is how we can automate that. All right, so let's see the dark side of Kubernetes. The dark side of Kubernetes, why? Because Kubernetes seems complex, it's not. And you need to understand a couple of things related to how it works, how it's been orchestrated, and the various events that could be generated by Kubernetes during the workload cycle of your workload. So in Kubernetes, of course, you know, it's an orchestration platform for containers. It relies on nodes. Nodes are basically virtual machines or physical machines. And you have two types of nodes. So the master node in the top with all the icons that will have the scheduler, the etcd, the control manager, and so on. And then at the bottom, you have your worker nodes. What happened when I deploy? So when I deploy, I interact with the API server. The API server goes to the scheduler, and the scheduler will try to find a node. So the first step is, okay, let's find the node who can take my workload. And the way we select nodes in Kubernetes is based on resources and various policies that you may apply, like tails and tolerance or label selectors and other stuff. Once we have the node, so our workload was in pending state, we move to the next state, which is creating. So because we rely on containers, obviously we need to pull out the image from a Docker registry. So we will probably throw events if the image is not there. And if you also requires to work with volumes or secrets or whatever it is, it will also throw some events about, yeah, there is something missing. Once everything is there, of course, we move to the running state. So here we officially starting the container. So our application is not running, but at least it's starting. It's a good sign. So let me explain you a story. So here I have one master node and I have one worker node. In fact, I have more nodes in reality. And I have two applications. So here the applications are represented by pods. So don't think it's just pod, it's applications. And I have two applications. One is very critical and the other one, all right. It's not a big deal if it fails. And the one that was less important were consuming more and more resources. And as a consequence, because it was eating more resources, my node started to be in pressure. And because if you know Kubernetes, when you have a node pressure event, what would happen? Kubernetes will try to avoid as much as possible infrastructure issues, so it will start an eviction. So what does that mean, eviction? Eviction means Kubernetes selects a pod available in that node, and it will kill it, and it will reschedule it on another node. So here, Everything went fine. I had enough resources. Everything went smooth. So in fact, no major downtime. Nobody, in fact, saw the problem. Whew, I'm so happy about it. But it could be worse. It could be very, very worse. It could be worse where I'm not able to reschedule anymore. So I killed my workload, but there's no nodes left to take my new workload. So which means I have deleted something. My app is obviously down, and nothing is taking over. So my user now, they are seeing that something is going wrong. So how can we resolve this? So first, let's see of the traditional Kubernetes requirements for this. When eviction happens by selecting pods based on the quality of service. So what is the quality of service? You know, it's based on requests and limits that are defined on your pods. So if you have no limits defined, it's going to be best effort. So that will be the first level, will be deleted as a priority. Then you have the burstable. The burstable is when the request is under the limit. And then last, you have the guarantees, where the request equals the limits. So if you define properly your requests and limits, at least Kubernetes will evict pods in that order. So burst effort, then burstable, and last, guaranteed. The second recommendation, in my case, it was 2 applications, so 2 different namespaces. I should have applied a resource quota in my namespace. In that situation, at least I know that that namespace won't be able to consume more resources than it was allowed. Of course, you have other recommendations, but let's skip to those 2 recommendations. So let's have a look a bit more on the request and limits, because we know it's important. So what is a request? So let's think that Kubernetes is about like Tetris. I'm pretty sure that everyone knows Tetris. Have you played Tetris? Yeah, of course. So the principle of Tetris, you have a shape coming down, you move the shape, and you place it in an available spot to win points. All right, so it's the same thing. Kubernetes sees a deployment, and based on the shape of the deployment, the size of the request, he will put it on an available node. So if you define the request, then Kubernetes is optimized to place it on the right node that is able to take that workload. So if you don't define requests and limits, then Tetris doesn't make sense. You will always have those tiny shapes coming down, and then suddenly those tiny shapes grow, and then it's impossible to win. It's impossible to win points. So request and limit the request is for that purpose. So you express it in MIDI cores, if for the CPU, and memory in bytes. So if you do the right testing, you know at least in advance how much resources you need to at least start your workload. Of course, if you just want to guess, let's put a very high value. All right, I can do that, of course. But keep in mind that Kubernetes will allocate those resources. So your nodes will be fully used, but in fact, those resources won't be utilized because it's been allocated but never used. So try to optimize at least the request. The second aspect is the limits. So we have now defined that we want to live in a 2-bed apartment, all right? And now the owner, Kubernetes, sets some contract with us. So you can consume a specific amount of water per day and a specific amount of power per day. So here, we know it could be very, we can understand about this. So how do we express it? In memory, it's going to be in bytes. So if we do the right load test or capacity planning, we can figure out how much bytes do I need in maximum to handle the load. The other aspect is CPU. CPU here is in function timing, so it's different. Why is it in function timing? I think you pretty much, all of you knows, is because we rely on containers. So the way it's shared, the CPU is based on cgroup and CFS. And to be very simple, to remind it, one core has one CPU cycle of one core is 100 milliseconds. So we have 100 milliseconds, and we define how much time I can consume within that core. So if let's say I have a function time of 20 milliseconds, I do my work, 20 milliseconds, and after that time, because I'm not allowed to consume more than 20 milliseconds, AB will be paused, and then for the next 80 milliseconds I wait, and then the system says, hey, you can start again, so I rework again for 20 milliseconds, and then I'm paused again, and so on and so forth. And that mechanism to be paused and started and paused and started, this is throttling. It's CPU throttling. So imagine you have a process running, and suddenly he starts to do some stuff, and suddenly someone says, hey, pause, all right? And then you can resume. So you can think about the impact on the behavior of applications if you have too much CPU throttling. So the limits at the end, if you want to define it, if they are to define too low, you have CPU throttling on the CPU side, and in the case of memory, you will have events like OM kill. You know all that. Everyone has been facing at least once an OM kill event. And if you define those values too high in the other end, of course, your resources won't be utilized properly. So what I did, I said, all right, that's cool, but let's do a test. So I did a test, small load test. I removed all my limits on my workload, and then I reapplied them. And without the limits, of course, if you look at the top on the graph on the top, it's a CPU. Okay, so I can see that with the limits, of course, I'm utilizing less CPU. No surprise, I was expecting this. Now I'm looking at the response times. And the response times without the limit, I had about 200 milliseconds of response times. And with the limits, I reached out 3.6 seconds. So here, you can say, wow. And this is just about CPU throttling. So again, it means that if our team is not defining properly those settings, then we can expect major problems and major bad behavior for our users. And we are not the only one facing this. If you look at KubeCon, on most of the talks that happens over the years at KubeCon, there is major company like Airbnb, Zalando, and many others that has shared their experience with major production outage related to CPU throttling or OM kill events. So it's real. You need to be to be aware of that. So here there's a QR code, by the way, where there is a website listing all of those failures. So if you want to have fun and listen to those presentations, it's always good to listen to horror stories. So how can we resolve this? Well, for this, no surprise, chaos engineering. So let's have a look at the definition in Wikipedia. The first reaction is, let's have a look at the definition. So chaos engineering is a process to discover vulnerabilities by injecting failures and errors. All right, and then it says in production. And I'm come from the performance engineering world and say, what? Production? Nah. So, okay, you can do it in production for sure, but before you do in production and have fun in production, try to be a bit mature and do it on testing environment for sure. So the chaos workflow, how do it work? So first, we need to define a hypothesis. So we have designed a system, and we have to define on what could be what could turn wrong, all right? So if I have an application discussing with a database, what happens if I disconnect the link? All right, so I'm not able to read, unable to write. That's fair enough, I know it. So I can predict how my system can behave based on those problems. Then I need to define the KPI that will allow me to measure if my experience went well, or on the other hand, my experience went very bad. Once I've defined those hypotheses, I need to define the flow, because if I need to inject an experiment, I probably have several steps to turn off something or cut down a link, whatever. So I have a real workflow of tasks to be executed to make that experience happening. Then, remember, we're going to run it in production, so we also have to describe how we're going to roll back. If there is a problem, I need to come back to a normal situation. And last, because we're going to collect some indicators, some metrics, we need to also define how we're going to collect those metrics. And last, once everything is defined, we can run, obviously, our experiments. So what type of hypothesis we can define for Kubernetes? A couple of them. The first one is Kubernetes settings. We talked about it. So if someone defined bad requests and limits, my expectation is my team is just wonderful and awesome. So stable, performant, I never question my team for sure. And low error rate. Last is maintenance. Remember, you rely on Kubernetes nodes. There's new versions coming out on Kubernetes, and you need to upgrade them. So how do you upgrade a Kubernetes cluster? You know, you have to remove the node, you do the maintenance, and then you reattach the node to the cluster. So it means that during some few production hours, it means you will run with less nodes than expected. So if we have designed our cluster pretty well, I expect that if I remove a node, nothing happens. And last, eviction. Eviction, we talked about it, so that's my major problem that I want to share. So I expect as well that everyone has defined pretty good quality of services. So I don't want to have major downtime on my critical application. On the other ones, we can discuss, but on the critical ones, I don't want to have any downtime. We need observability, we discussed about it, so let's have a look at the different pillars of observability. So we have logs, we have Kubernetes events, we have metrics, we have traces, we have continuous profiling, but here we are talking about an infrastructure problem. So I don't care about traces. I don't care about continuous profiling. I will basically just limit my observability to metrics and events and potentially logs as well. So what are the important metrics and events for this? So Kubernetes is an onion. There is several layers. The first layer is sitting outside of the cluster. It's our users. So to measure if there is an impact, I need to measure the response times, if it's acceptable and stable. And then the failure rates. If I'm having a lot of errors, then of course there is a problem. Then move on to the next layer. We have the node. So here the node, we have resources, CPU, memory, the number of pods running. We can also check at the number of port allocated, and so on. On the pod, we're going to look at what has been requested, what is the limit, and of course, what is the usage. Did we define something efficient or not? And then everything related to CPU throttling is on the container level, so we're going to look at the CPU throttling at the container level, the memory usage, and CPU usage as well. Now on the event side, there's plenty of events. I mean, Kubernetes is throwing so much events, so it's pretty rich. So on the node, we can look at node pressure, because node pressure could be a sign of eviction. Disk pressure as well is also a sign of eviction. We can have a node port conflict, also is very important. And then on the pod level, I will look at everything that could be a sign of there's a problem of scheduling. If there's a problem of scheduling, it could be a sign of a problem of a node. So failed scheduling is obviously very important. Eviction, of course, we talked about it. OM kill, we can all have unhealthy. That could be also an interesting event to look at. What will be the experiments that we're going to run in Kubernetes? So let's have a look at eviction and maintenance. To be able to test or simulate the eviction, if I have a cluster with a lot of nodes, it will be very difficult to make the pressure on my cluster. So for this, what I do, I will remove nodes. So that's why I'm saying, why don't I combine my two requirements? So on the first piece, I will remove nodes. And to measure the impact, I will of course have a load test running, because remember, I'm not doing this in production. So I'm running a small load test, constant load, just to measure the impact of the user and the response times. And I remove the nodes and figure out how is the impact for the users. Once we have removed all the nodes that was required, then I can start my experiments. So I will generate some CPU hog on the node, I will memory hog on the node, anything that could make some pressure and start the eviction happening. Then we have the Kubernetes settings. For this, you don't necessarily need a pure experiment. You can just need a constant load without any settings, any requested limits, and do the same with the limits, and then fine-tune the limits. Basically, it's tuning the settings that has been defined in the workload files. So what do you need for this? So first big requirement, if you do it on testing environment, I would have dedicated nodes for my app and dedicated nodes for my application, for my testing solutions. So it could be load testing or chaos engineering. Why I'm doing this? Because when I run my experiments, I don't want to have the experiments putting pressure on my chaos experiment tool or on my load testing tool. So separate the nodes is the first requirement. The second thing is you need a chaos engineering tool, and I pretty like Litmus Chaos, so check it out. There's plenty of chaos engineering tools, but Litmus Chaos is pretty mature. It has a web UI called the Chaos Center. You can either install it on the same cluster, or you can have a remote cluster. So you can have another cluster, and then for this, you need, of course, to deploy in your cluster an agent that will allow us to inject the experiments. And the great thing is Litmus expose metrics. So we can have already metrics coming in. Well, how was my experience running? And the other advantage of Litmus, it has a Chaos Hub, and all the experiments that we need for our Kubernetes are already defined, so I don't have to reinvent the wheel. Then for the load testing, you can use plenty of tools. I use K6. Why? Because K6 has an integration with Prometheus, and if I want to be able to collect metrics and see everything in a very smooth way, yeah, that's why I take advantage of that output plugin. I will have Prometheus that comes with a couple of The operator comes with a couple of exporters that give me the health of the cluster. Litmus is exposing metrics and K6, but in my case, I want to use Dynatrace, and also you have to use Dynatrace, and just joking. But if I have Prometheus running, I can just simply input annotations on the pods, on the metrics that I don't have in Dynatrace, in my case, Litmus and K6, and Dynatrace will automatically pick up those metrics because it's Prometheus. How can we automate that? Well, because now we did everything on a manual way. That's fair, that's fine, it's cool, but we don't want to do that every week. It's going to be just time consuming. So let's have a look at pipeline. So we can define a pipeline. I know I can automate, so I will build, I will deploy exporters, so I configure everything to collect the new metrics. Then I run my tests with Litmus and K6, and then nothing happens. Someone needs to look at the results. So do we call that an automation? No, that's not automation. So how can we make that analysis very quickly? Well, for this, I have a tool to introduce. I don't know if you know, but there's a tool out there called Captain. Captain is an open source solution from CNCF, where Dynatrace has invested in this tool so many years. It could do tons of things. It could do all the entire progress delivery, the quality gate. That's the use case I'm interested in fact, auto remediation production. But how you define Captain? Captain is an orchestration framework based on events, based on cloud events. So tools register to the event, and once the tool receives the event, it does the work, and then you can move over. So it's very smooth and easy to use. The configuration based on YAML files, so you don't need those very complex pipeline files anymore. It's much more easier. And it has tons of integrations. So here in my case, I'm interested in the quality gate. And why I'm interested in this? Because it's going to use SLI and SLO. And this, we all love here SLI and SLO, so it's perfect. So let's have a look at the first pipeline we had, where we had a pause of a couple of days to have someone saying, hey, it's good, you can move over. Here it's going to be different. So we build, we deploy, we run our test. And just after running the test, I'm going to send an API call to Captain. And Captain say, okay, so have an SLO file defined with a couple of indicators. So pod failure rates, the node pressure, blah, 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 different metrics that we've defined. So Captain will reach out to the observability solution holding the metrics. He will get the metrics back, and then he will look at the SLO defined. And based on the SLO, we will get points. And at the end, what we are getting is a score, which means I can put an SLA on the score. I tolerate that my tests are efficient or good enough if I've got a score above 85, for example. So now, instead of waiting, I don't know, an hour, 5 days, 3 days, whatever, depends on how much time we need to evaluate the success of our test, it takes less than a minute. So now we are talking about automation. So with Captain, you are able to do that, and it helps you to also validate and improve your SLI and SLO in a testing approach. So a couple of takeaways after this presentation. So first, in Kubernetes, we need to define quality of services. We know about it, but we have to do it because it's going to help us in general. We need to define resource quotas on a namespace, especially if you separate your apps by namespaces. And then on an observability level, of course, collect metrics, collect logs, collect everything. You need to understand what's going on. So if you don't have observability, then you are blind. You're not able to understand things. And then as an SRE, utilize chaos engineering in a smart way. So combine it with load testing. Don't think that load testing is only for performance engineers. Load testing is also your friend. And last, define SLI and SLO. Of course, you know about it, but not only on production, but also in other environment than production. Before we close up this presentation, quick promotion on Is Observable. So there's plenty of tutorials. There's one on Litmus Chaos, by the way. And again, there's I need feedback. So it's a very young YouTube channel. So, but I can improve the content if I get feedback. So check it out and send me your feedback. Thank you.